Oh man, oh, geothermal energy makes me feel young all over. Yeah, let's look at some geothermal ground source heat pumps. Yeah.
Ah, don't be such a baby. So remember, your all your sources are right here in the central column. Take a look at ground source heat pumps.
Kenza Engineering have been manufacturing and installing ground source heat pumps since 1999. With over 2,500 complete systems manufactured so far, you can trust Kenza to deliver award-winning expertise and advice. In this video, you will learn how a ground source heat pump works. The purpose of a heat pump is to absorb low-grade heat in one place where it is plentiful, then to transport, concentrate and release it in another location where it can be used for space or water heating. The ground absorbs low-grade solar energy by means of direct sunlight and rain. This gives the ground a year-round temperature of around 8 to 12 degrees Celsius.
But we know that that's just about 2% of the actual heat, isn't it? The heat comes from the mantle and from the core of the earth. There we go.
But how can this low-grade heat be used to heat an entire building? A cold water antifreeze mix is pumped through the ground within a series of energy-absorbing pipes known as ground arrays. As heat naturally flows from warmer to cooler places, the antifreeze mix circulating around the array is constantly warmed by the ground's low-grade heat. Having increased in temperature, the antifreeze mixture is fed into a heat exchanger called the evaporator. Within the secondary sealed side of the evaporator heat exchanger is a refrigerant which acts as a heat transfer fluid. When the water antifreeze mixture enters the evaporator, the energy absorbed from the ground is transferred into the refrigerant, which begins to boil and turn into a gas. The refrigerant never physically mixes with the water antifreeze mixture. They are separated like sandwich layers by the plates of the heat exchanger, which permits the heat transfer. This gas is then fed into a compressor. The pressure of the refrigerant gas is increased in the compressor, which makes the gas temperature rise. The hot refrigerant gas then flows into a second heat exchanger called a condenser, which features an identical set of heat transfer plates. The condenser delivers water hot enough to serve the space heating system and, if required, the property's hot water needs. Having transferred its heat, the refrigerant gas reverts to a liquid. This liquid is then passed through an expansion valve at the end of the cycle to reduce its pressure and temperature, ready to commence the cycle all over again. Low-grade heat stored in the ground has been upgraded by the refrigeration process to deliver hot water. For each kilowatt consumed by the heat pump, 4 kilowatts of energy is generated, effectively meaning the cost per kilowatt hour is quartered. Plenty more information can be found on the company website or in other Kenza videos. Please also consider attending a one-day Kenza training course or utilize the e-learning installer training tool at www.kenzaengineering.com/training tool.
We'll have to look at that.
Kenza looks forward to working with you.
The engineering tool. We'll look at that. So let's take a quick look here at a pre-packaged system. Pre-manufactured TerraSource.
TerraSource has made geothermal heating and cooling affordable for all homeowners. Our pre-engineered systems reduce standard installation costs by up to 30% or save even more with a do-it-yourself kit. Standard system includes our Climate Master heat pump, copper manifolds including Grundfos pumps and standard brass mechanical components, ASTM certified plastic polymer loop pipe pre-charged with environmentally safe antifreeze. Everything is color-coded and labeled for easy installation. Installation is accomplished in 4 easy steps. Installation of loops, manifold, plumbing, and electrical. The first step is the excavation of loop fields. The horizontal loop is the most common and needs around 250 feet of continuous trench as shown in this example. House size and BTU requirements will determine how many loops are needed. Available land will determine the type of loop required. We have included some common dimensions for this example. The loop is placed in the excavated ditch. This example demonstrates how a 4-pipe and 6-pipe horizontal loop will be placed in the excavated ditch. A slinky loop is used when land space is restricted. In this example, we used 100 lineal foot trenches to provide enough length for the system to be energy efficient. A vertical loop is used when the required space for horizontal trenches cannot be achieved. Approximately 6-inch holes are drilled and loops are installed and grouted. Inside the house, we will connect the loops to the manifold. First, cut off any slack on each loop end. Each loop has a quick connect fitting that inserts into the manifold port. Then a fresh water source is connected to the manifold. This will be used to fill the loops later. The ductwork, manifold, and optional water heater are now connected to the heat pump through easily identified connections. Next, connect the thermostat to the color-coded thermostat wire provided. Both the color-coded thermostat wire and control wire from the manifold are plugged into the heat pump. To finish, fresh water is added. By using the port valve, each loop can be isolated and purged independently, thus eliminating the need for a flush cart. Antifreeze will mix throughout the loop field, while air is purged from the system. Your system is now up and running, and you will begin to realize some energy savings. The system can be installed by a TerraSource certified installer, or we can provide everything you need except for the digging and ductwork for a do-it-yourself install. Call 877-443-6349 today, or fill out the quick contact form on our website, and a geothermal specialist will send you your free quote for the geothermal system that is right for you.
Yeah, we got it. TerraSource. Nice.